So we're talking about psychrometrics today, for Larry and I, I'm sure they're really interested in this part. So if you're ever listening to the radio and hear today will be a high of 25 with a humidity of 95%, hear something like that, right? Yeah, that's right, yeah. What exactly does that mean? Well, you know, today we'll learn about a psychrometric chart. So a psychrometric chart is more in the part like when we're wanting to find out exterior air coming in, so because the outside air can be humid, moist, right? Our humidity's in there, and then with our refrigeration or heating, what do we have to do for that part in order to make it comfortable for human health? So kind of like a 20 degrees Celsius kind of part, so a 25 degrees C coming in, a little warm. No one wants to be at 25 degrees inside, and the high humidity, it's not we got to be feeling sticky and all that, so we've got to remove some humidity from that as well. So with a psychrometric chart, we can plot data points on there, and then we can extract data from that as well. So it's the study of the behavior of mixtures of air and water vapor, how they kind of play around together. So it's only 2 data points. We can find 5 additional data points. So today we're only going to cover 4, just due to time constraints. And so from this we can find our dB, which is our dry bulb. So that's kind of our normal temperature that we get. So it's all on your handout there, the skeleton as they call it, with the color part, and then the other charts broken down. So you can find our dry bulb temperature. Our wet bulb temperature. Our wet bulb is actually with like how much, because water can remove heat energy, so how much is our temperature with that evaporation, our removal of heat? How does that factor in? Our dew point temperature, so you know in this time of year, when we start getting cold nights and that dew, how does the dew fall on our leaves, wreck crops, that whole point? The dew point temperature tying in there. And our relative humidity, so that's our RH as it's known. So on the scale you can find out there's also specific humidity, enthalpy, and specific volume, but we won't worry about those parts today. So the dry bulb is our regular that you'll see, a regular standard thermometer hanging out. That's our ordinary thermometer that we read from there. The temperatures are plotted on the vertical line, so we read it along the bottom on your scale. So you see that big chart there, the psychrometric chart paper. It has here at the bottom dry bulb temperature. Blue, yeah. Dry bulb, yeah. Haven't you got that?
I think so.
Yeah, okay. You're good. Okay. So we read up with them as well. So you kind of catch it on the bottom. We go up vertically with the numbers on our dry bulb. And there's our wet bulb. So as I mentioned, it's a wetted bulb, a wetted wick of it, and we immerse it in air, whirling, sometimes getting a fan blowing on it or like sling them around. The wet bulb temperatures are plotted on a kind of a 45-degree angle on our chart. So they start on the saturated line here, so it's at the saturation point, that's where essentially we're getting rain. Like that's where the air can no longer hold any more water vapor, so it's falling out, kind of like what we have out there with a bit of fog going on. So they slope downward to the right. Our dew point is the temperature of the air, saturation, or the temperature at which the air must be cooled before condensation will begin. So that's a whole part of rain as well, with that dew point, how it's dropping out of the sky. Sure, okay. So our relative humidity is the ratio of the actual amount of water vapor present in the air to the amount of water vapor the air could hold when saturated. So essentially, with our relative humidity, say this is in the middle, so let's say our 50%. Up here, the saturation line, that's where we're going to have rain, but anywhere around there, and that's where, like, say it's too dry, you know, we might have mucousy issues, like when our nose dries out, our mouth, you know, that whole part in low humidity, plants start to kind of not like wood creeks. But a high humidity, that can cause issues with swelling with wood products as well, and just kind of underlying issues with it as well.
Pianos.
Okay, so we're going to use our chart. So we've covered a bit of it. So you guys have the same outline in front of you as well for the chart. So our step 1 part of it is locating 25 degrees Celsius in the dry bulb scale. So remember along the bottom, it's 25 degrees C. Okay, so then we actually want to find the wet bulb. So I will try and do this along with you. So our dry bulb's at 25, right? 25 is there. And then we're going to increase, but we take our line up. So this is where your straight edge kind of comes. So you can run that, it's a bluish line, say, from our 25. And actually the 25 is up here at the top too, as well. So the number of the scales are kind of line, and we kind of go top and bottom. Combine the two. Okay, and then our second point that the sheet told us about is that our wet bulb temperature, so that's the whole over evaporation, it's removed the temperature from there. So it's say on 18, so we kind of go from 20 here, so this is kind of our wet bulb temperature scale. So we have 20, we have 19 there, and that's our 18. So just 2 ticks down from 20 is our wet bulb of 18 is here. And then we can just run that 45 down. It's kind of a redder line for those that can see color. And then our point of intersection, that is, say, our data point for our 2. So all we really need is these 2. But if you remember that skeleton chart, any of the other 7, we could find out the same information from that. So from here, we can see we have a little bit higher than 50% relative humidity. And then we can also go, there's other parts of our specific volume is say 86, or well, 84 to 80. So 85, high 0.8085, so our 0.85. So a lot of times you don't have to be too exact when it comes to these parts, but we can see a lot of different information. If we go horizontally across, we can see it's 0.01 moisture content, so per kilogram of dry air. So there's a lot of different information points we can grab for that. We can also find our dew point. So our dew points, we have 10, 11, 12, 13, 14.
So 14 degrees.
Yes.
The moisture will turn to rain.
Right. So there's the dew point. We can find it actually on this whole saturation line as well. So it goes horizontally over. That's our 14 for our dew point.
Oh, okay.
And then it's also on that side as well. So the dew point there. Corey, see that? Yeah. Okay. Yes. So we found that. We can find the specific humidity, which is kind of what I mentioned as well. So that's just on the whole lines. So the chart has it kind of in here. So it's relative humidity here as well on that arc. So that's where our 50.
So we're looking for specific humidity?
Sure. Yes.
Oh no,
Yeah, so the specific humidity is kind of the moisture content of that.
Okay.
So that's on that 0.01.
Okay, all right, so that's our horizontal.
Yeah.
Okay, gotcha.
So if you want, there's a bit of more time. You can also go ahead to try your other points of, say, the other extra questions there. So 20 degrees Celsius is our wet bulb, and or sorry, our dry bulb, and our wet bulb is 15. So you just do the exact same points from that, and we can extract data.
Can I ask you again
Sure.
what the central point means?
That's just our intersecting of lines. So it's kind of like to find out all the extra information we can, we need to locate that.
So they give you the dry bulb and the wet bulb, and you can find out what temperature,
Yeah,
how
like
much
the relative
humidity,
humidity is. Yeah.
all those other things from that.
Okay, so there's no major reason why we should be interested in where they intersect then?
It's just that they need to intersect, and then from that is where we can find the information for that that part. So it's, as I mentioned earlier, it's the part of, say, we're extracting air from the outside, and we kind of want to know, okay, today it's really wet, so we might have to dehumidify the air a bit before it comes in. So
50%.
where our part is, what pieces of equipment we're
It's
removing.
like an algebraic formula that has 1, 2, 3, 4, 5, 6, 7 letters in it, and
The
they give you
specific volume runs
So
along
dimensions,
on this part right here.
7-dimensional graph.
So
Oh,
the chart,
okay,
yeah, the
so
chart's kind of
actually-
labeled, yeah, so it's
Oh,
on
you
here.
got
We
it?
didn't completely cover it, but that's because you're inquisitive.
Yeah,
Embracing it.
yeah, it's great, once you can get it broken down.
you guys good with that for now? Yes? So we covered the relative humidity, right? So we know how much kind of the humidity's in the air, the water vapor in there, the dry bulb temperature, so that's standard temperature what we read. Then there's the wet bulb temperature.
This is the intersection
So that's the
point.
evaporation removed
This
from
is
our
the
thermometer.
point for the question.
Oh, good question. So then that would be your closest one.
Okay.
Greg,
So this is
yanking me off the stage here.